Welcome back, students. My name is Dolon Banerjee and I was continuing with the video lectures organized by AKTU for the subject of geotechnical engineering in the civil engineering stream. So, in the last class we were talking about the compressibility and consolidation. We studied the procedure of the consolidation. Now, we will get into the types of clays, okay, according to the consolidation and stress history. Okay. So, let us continue. The need of stress history of soil. The need of stress history of the soil. What is stress history? Actually, stress history means that perhaps at a time in the history of the soil, the soil might have got a overburden which was greater than the overburden or the stress which it is considering now on it. Okay. So, we will be seeing into these things and we will also get into the how this is used or what is the use of this stress history in the engineering purpose. Okay. So, let us see. In natural deposition process, fine grained soils like silt, clay undergo the process of consolidation under their own weight of overburden pressure. A state of equilibrium is reached after an elapse of several years and the compression ceases. What does this mean? That due to its own overburden pressure also means that suppose how is a process, how does the process takes place? First of all, you have to understand that there is a deposition of soil particles. Okay. There is we have already studied about transported soil and the lacustrine soil and the residual soil and all. So, that there are how are the soil formed. So, let us say that this is the soil formation process. The soil particles are something like this. Okay. This is the soil particle. Okay. They have come from some other part and got deposited here. Okay. Now, for this point of time they will be loose soil because they have just been deposited, they will be loose in nature. Further, with the time what will happen, these soil will be again overlain by another layer of the soil. Okay. Another layer particles will be there, something like this. The particle will go on increasing. Okay. Something now this has increased. Okay. Like this. Now, suppose this was our initial, now this much is later on which is again deposited onto this. What will happen? This part will exert stress on this, okay, due to which this will get compacted or consolidated to an extent. Okay. So, this is what it is telling, that under its own overburden pressure also consolidation can take place, okay, in the fine grained soil mainly. And after a ellipse of several years, the compression gets ceased, means after the deposition, let us say some more deposition of the soil particles took place later on, okay, something like this, okay, like this. Again after some time again some particles took place, but after a time the deposition ceases at this part, okay, it becomes something like this, a ground finally comes to an existence. So, later on this much stress is being beared by this part. So, after a time the how much consolidation it had to be taken place will slowly take place and finally, the ground will become like this and in lower part it will be consolidated. So, the soil particles will come nearer to each other, something like this. Okay, something like this. So, this is the first point. This process continues season after season and sometimes erosion or removal of the overburden takes place, and sometimes the process of consolidation may continuously take place due to frequent deposition. As I have already told you that deposition may take place time and often at a part, and sometimes the opposite may also happen, the erosion may also take place from this part. It need not be that only deposition is taking place, perhaps the erosion may also take place. Now, once the erosion will take place, what will happen? Erosion will take place, then the upper layer will get removed from the soil. Okay. So, if it was first of all say bearing sigma 1 stress, now due to the removal of the top layer, what will happen, the stress will get reduced obviously. Okay. Let us say now it is bearing sigma 2, now sigma 1 will be obviously greater than the sigma 2. Okay. So, this is what it is saying. So, it is evident that clay deposit exists in the field under different conditions and their stress history should be known. Okay. Now, we can understand that now if the ground is in this condition, this means it has already taken stress higher than what it is taking at the present time, and if it is in this state, then it is already in the highest state. Okay. So, these are later on used for the classification of the soil. Okay. Now, types of clay deposits depending upon the stress history, how we will classify. First of all, normally consolidated soil or NCS. Okay. If the present effective overburden pressure in the deposit is maximum pressure to which the deposit has ever been consolidated at any time in the past, such a deposit is called normally consolidated clay deposit. There is no reliable procedure available to predict in situ effective void ratio, effective stress and void ratio relationship. In a field EP relationship has to be obtained from a carefully obtained undisturbed soil sample. So, first of all, just understand what is NCS. I am sorry, NCC it will be normally consolidated clay, or NCS when it is normally consolidated soil. Okay. So, what is normally consolidated soil? Just now I told you, it is that soil which is stressed to maximum, or which is stressed to that stress which is for the first time in its stress history. Okay. As in the previous case, if in this case this was the case, after its settlement we finally got this one. Okay. So, talking about this part of the soil, this will be termed as normally consolidated clay. Why? Because it is already subjected to the maximum stress which it has ever subjected to. Okay. So, this is its maximum stress. So, this is what it is telling us. Present effective overburden pressure in the deposit is maximum pressure to which the deposit has ever been consolidated. Okay. This is what NCS or NCC means. Besides, we actually develop a relationship between E and P, means effective stress and void ratio. Okay. By using the undisturbed soil sample, we will come into this also. You can see here now, for normally consolidated, either we plot E and log P. What is this? Stress. Okay. Effective stress, and or E and P, either log or just simple curve. Okay. Influenced depending on the degree of disturbance. Increase in the degree of disturbance flattens the curve considerably, but the straight portion converges at low void ratio as shown in the figure. You can see this is the E and log sigma bar curve. Okay. And this is log P and this. So, here you can see this is the virgin curve. What is virgin curve? Virgin curve is actually the normally consolidated soil curve. Okay. Why it is called virgin curve? Because it is first time applied to that much stress. So, it is called virgin curve, and this is the straight part. Okay. This is the straight part. This one unloading and reloading. So, this is also called rebound curve. This is called as rebound curve. Let me make it here. It's something like this and again like this. Okay. This is called rebound curve. Rebound curve. Why rebound curve? Because you can see unloading is being done here. Okay. So, once the load is being removed, what will happen? The soil, okay, which was stressed and very close to each other, something like this, now will try to move out or relax itself. So, the particles will try to move further away from them, due to which volume will increase, So, this part will form. Okay. Rebound curve. Again, if you do reloading, what will happen? this type of curve will form, but this was virgin compression because for first time the load was being applied. Okay. But now this won't be a virgin compression because already we have applied that much load. So, this will be a recompression curve. Recompression curve. This will be a recompression curve and this will be a virgin compression curve. Okay, and this is the rebound curve. Again, this much part again. Remember that this will be again a virgin compression curve because this is a different story. Okay. So, this is what it was telling us. This is the E and log P graph, and here you can see it is according to the pressure. Okay, how the pressure varies with E. Okay, virgin curve had to be something like this. It had to be, but as there is written that disturbances, due to disturbances, the degree of we can say the convergence also gets deferred. So, you can see actually the curve was to be something like this, but due to disturbance it became like this, and again further disturbance it will again flatten more. Okay, here it is written disturbance flattens the curve considerably. This is what it is. Actually it had to be, if there is a very little or undisturbed, then something like this, further more disturbance like this, again more disturbance, then like this, it will slowly flatten. Okay, this is what, this is according to the effect of disturbance. So, you can understand that the more the undisturbed sample we are obtaining, we will be nearer to the real one. We will be actually nearer to the real virgin curve. Okay. Further, the in situ void ratio may be taken equal to the initial void ratio at the start of the test without appreciable loss of accuracy. Further, for normally consolidated clay, the pre-consolidation pressure is equal to the effective overburden pressure. What it is telling us that virgin curve, I have already told you what is the virgin curve. This part, let us see what it is telling us. This is telling us that we need E naught. Okay. If you remember the formula of U also, E naught minus E upon E naught minus E f, something like this. Okay. So, in general case it is telling that if you do not have the value of E naught, then you can just take the initial void ratio as the in situ void ratio. Okay. These two can be taken as to be equal. Okay. Besides, if we do not have the pre-consolidation pressure, then we can take it as effective overburden pressure. How to calculate this effective overburden pressure, we will learn it in the other chapters. Okay, forthcoming chapters. So, just for the time being, you have to remember that if we do not have the pre-consolidation pressure, then we will take it equal to be with the effective overburden pressure. Overburden pressure, you can understood, I think, physically, that if the soil, we are talking about this layer of the soil, something like this here. Okay, if we are talking about this soil layer, okay, then this all soil, this whole soil is the overburden pressure. This is causing an overburden pressure because it is lied on this soil. So, this is an overburden, and the pressure exerted by this on this layer will be the overburden pressure. Okay. Now, over consolidated clay, that was normally consolidated. Now, we will talk about over consolidated clay. A soil or clay soil deposit that has been fully consolidated under a pressure P c in the past larger than the present overburden pressure P naught is called as over consolidated or pre-consolidated or pre-compressed clay deposit. Okay. The ratio of OCR we will read later on also. OCR is over consolidation ratio. It is a very important parameter because it helps us to understand whether a soil is normally consolidated or pre-consolidated or under consolidated. Okay. So, for the time being, just let the formula be this consolidated minus initial upon initial. Okay. So, this, let us go into that figure again. In this case, in this figure, if we are talking about over consolidated clay, then over consolidated clay will be which one? This one. Why? Because this much part, if you remember, I told that this much was eroded or removed out. Okay. So, this will get relaxation, this layer will get relaxation. Okay. due to which it will move out and expand. So, but if we talk about this layer, then what we can say that this has already beared a stress greater than what it is now bearing, because this much layer was first of all kept on this. Now, this is removed. So, this is only here. So, this much layer has already beared extra stress of this also. So, this is an over consolidated clay. Okay. This is an over consolidated. This was an normally consolidated, this is an over consolidated clay. Okay. Further, over consolidation of soil may be caused by any of or a combination of the following loads. What may be the load? Pressure due to overburden which has been removed, just like that example which I had given to you. Okay. It may be a structure as well, some structure was there and now it is demolished. So, this part will be over consolidated. Glacial ice sheets which have been disappeared, means suppose this is the soil. Okay. This is a soil deposit, something like this. Here was a glacier, you can say the glacier was there, but due to heat it got melted away. Okay. It got melted away. Now, there is only this soil. So, it has already beared a stress greater than what it is now bearing. So, this is an over consolidated soil. Sustained seepage forces. Sustained seepage forces, what does this mean? If this is a soil, seepage is taking like this. What is seepage? Seepage means the movement of water in this direction. If this direction water moves downward, this will exert pressure on this soil skeleton. Okay. So, that it is talking about. Okay. Then tectonic forces or earthquake and all also may cause the over consolidation. Fluctuation in water table, means suppose something like this, here it is water, you know that water will be also here. Okay. Soil here will be under the hydrostatic pressure or pore water pressure will be inside this. Later on, if this water gets reduced, then this part was bearing higher pressure, now it is bearing lower pressure. So, this part will be over consolidated. Okay. The in situ EP relationship is radically changed by over consolidation. Factors other than pressure which may affect the in situ EP relationship are weathering, decomposition or deposition of cementation materials and leaching of ions from the pore water. This is not of much relevance. Just remember that the EP relation is also changed due to the over consolidation, means the graph which was like this. Yes. So, this will also consider, this also will be undergoing a considerable change, because this was a virgin and this was a recompression. Okay. So, something like this one. So, you can see the difference here. Okay. You can see the difference here. This is what we are talking about. The in situ E log P curve is obtained for using the following procedure. Consolidation tests are performed on the undisturbed samples and loading, unloading and reloading are continued till a reasonable straight line portion of E and log P graph is obtained. Okay. The pre-consolidation pressure PC is estimated. First of all, let us see the diagram. This, what they have done, loading, unloading, loading, unloading, reloading is done. You can see. Okay. This will be done a number of times, so that we can get the range of PC. Okay. So that we can get this part. Okay. After that, a line from the point G, okay, is drawn parallel to mean slope of the rebound curve. Which one was the rebound curve? If you remember, this was the rebound curve, mean slope of the rebound curve. So, this you can see G, you can see that G, at point G we have to draw. So, this is what, okay, nearly like this, parallel to this. Okay. This is drawn here, something like this. So, parallel to this it is drawn. Then what we have to do? Select a point G dash on the line corresponding to PC. From this point, a line is drawn to meet F of intersection of the laboratory curve point 2 E naught. So, now what they have done, in this line okay, they have taken a point G dash corresponding to the range of PC. Okay, the PC was ranging from there to there only, so we took a point here. Okay, so now we will do, we will now make further take a line something like this. Okay, further increase it and get a point which will be nearly equivalent to 0.42 E naught. Okay, so we will get this line now. Then the dotted dashed G, G dash and G dash F are used to obtain CC for calculating the settlement. Both the dotted line, which one? G, G dash and G dash F. G and G dash, okay, this part and G dash F. Okay, so this part will be used for the calculation of CC. Okay, we can use this also later on. This will be coming just now after this. Okay, underconsolidated clay. What is underconsolidated clay? We have read about normally consolidated. Okay, normally consolidated. We have read about the overconsolidated. Now underconsolidated. Actually, this underconsolidated is not of much use because it is taken into this only. You can see rapid natural deposition or deposits under recent fillings may not be fully consolidated under the present overburden pressure. Such a clay deposit is called underconsolidated. What does this mean? Means suppose there is a deposition, fresh deposition, okay, fresh deposition of soil, okay, but the deposition made on it is also very less, okay, very less deposition on it is there, due to which proper stress or proper consolidation of this part has not taken place. Okay, proper consolidation has not taken place. So, due to this, okay, due to improper consolidation, this will be termed as underconsolidation. Only this is the concept of underconsolidated clay. Okay. In such cases, PC is less than P naught and the structures constructed on this will go on additional compression. No specific procedure is available to get EP curve. However, for all practical purposes, this may be treated as NCS or normally consolidated for the purpose of calculating the settlement. Okay, as I have already told you, this is generally considered to be normally only. Okay, normally consolidated only. What is the difference? Just remember that this is not stressed properly, not stressed properly. Okay. So, due to this, what will happen? Now, if you make a structure here, a building something like this, okay, what will happen? A huge stress will come into it and it was not stressed properly. So, settlement will take place. Okay, settlement will take place and this building may go down something like this. Okay, this much settlement can take place. So, only drawback is there, if we construct anything on the underconsolidated clay, then settlement may take place if higher stress is applied. Okay. So, this is just a diagrammatic representation. You can see what will happen, okay, for underconsolidated clay. Some due to overburden, some part of the settlement has taken place. Now, if we put a structure on this, what will happen? Again, a settlement will take place this much. So, total reduction will be in the word ratio this much total reduction will take place, out of which for the time being only this much has taken place. A structure if you make on it, again this much will take place. So, settlement of this much will take place. So, it is risky. Okay. So, this was it. Now, just go through the questions, answer them. Okay. Reach me if some difficulty is there. Next time we will be talking about the compression of the soil and its measurements. Okay. So, keep watching the videos and also connect to share it with your friends and all, so that this new initiative can be further spread. Okay. Thank you.